Alright, in this question here we're asked to figure out the number of hydrogen atoms in 26.5 grams of water. By now you should be saying to yourself, hey self, I am going to have to figure out the number of moles before I can figure out anything else. So I'm just going to shrink up my data over there. Okay, in order to figure out the number of moles, of course we take our 26.5 grams and we divide it by our 18.02 grams per mole, and we end up with 1.4706 moles. And I'm going to keep all the digits in my calculator, and I'm only going to write a few extra ones. Now the trick here is to know that the formula for water is H2O. So if we have 1.47 moles of water, that means that we are going to have twice that many moles of hydrogen atoms. So we're going to figure out that we have 2.941.
Patrick and Lucas, could you go to classroom 204, please? Patrick and Lucas to 204.
2.94118 moles of hydrogen atoms, and that allows us, oh, I put that in the wrong spot. We have that many moles of hydrogen atoms, and we are going to multiply by Avogadro's number right there. And that's going to allow us to figure out the number of moles. Pardon me, the number of atoms. So we end up with 1.77 times 10 to the 24 atoms. Okay, to calculate the average, we're going to use the weighted average. We have 30.4% of the isotope that's 825 grams per mole, and we have 69.6% of the other isotope. So we calculate, we convert to a decimal, so it's 0.034 times 825.29, and that means that we have 250.888, and we have 0.696 of 838.42, so that gives us 583.540 for a grand total of 834 grams per mole. And we only get 3 significant digits because our percentages were only to 3 significant digits. So our average atomic mass is 834 grams per mole. Okay, we're going to write the isotope notation and the name for the atom that has 26 protons and 30 neutrons. If it has 26 protons, it is iron, and it has 26 protons. If it has 30 neutrons, that means it has 56 protons and neutrons in total, so this is indeed iron 56.